Students, today we are going to discuss about the subtraction of ramp signal in discrete time domain. So for that we have to define our ramp signal. What is R of n? R of n is equal to n for n greater than or equal to 0 and it is 0 for n less than 0. And so this is the graphical representation of R of n where the value is 0 at 0, at 1 the amplitude is 1, at time t is at a time n is equal to 2 the amplitude is 2, at n is equal to 3 amplitude is 3, at n is equal to 4 the amplitude is 4 and it goes up to your infinity. Okay. And then when coming to the second signal we have R of n minus 1. So how to represent your R of n minus 1? So this is nothing but time shifting operation. So for time shifting operation n minus 1 equate to 0. So we can find n is equal to 1, add this n is equal to 1 with all the values of n in R of n. So what happens? 0 plus 1 will become 1, 1 plus 1 will become 2, 2 plus 1 will become 3, 3 plus 1 will become 4, 4 plus 1 will become 5 and it will be going up to your infinity. Okay. So this is nothing but your R of n minus 1. So whatever you have at a 0 will be shifted to 1, whatever you have at 1 will be shifted to 2, whatever you have at 2 will be shifted to 3, it will be going on like that. Okay. So how you can represent your amplitude? So this position you will have 1, this is 2, this is 3, this is 4. Okay. So actually you will have the amplitude like this. Okay. So whatever you have at a 0 will get shifted to one location, whatever you have at 1 will be shifted to 2, whatever you have at 2 will be shifted to 3, whatever you have at 3 will be shifted to 4, whatever you have at 4 will be shifted to 5 and the signal will not end, it will be going on up to your infinity. Okay. So this is nothing but your R of n minus 1 signal. So this signal is R of n minus 1. So how you will obtain your 2 into R of n minus 1? The second operation is called amplitude scaling. So amplitude scaling in the sense only the amplitude you have to multiply by 2. Okay, whatever the scalar value they have given, that value you have to multiply with all the values of amplitude. So what happens? Your time remains the same, that is 0, 1, 2, 3, 4, 5, it will be going on up to your infinity, your time remains same, but your amplitude you have to multiply by 2. So 2, 4, 6, 8, it will be going on up to your infinity. Okay. So at a 0, here there is no signal at all, so it will be 0 only. Okay. At 1 also the amplitude is 0, 0 into 2 will be of 0 only. At 2 the amplitude is 1 here, so 2 into 1 will be 2. At 3 the amplitude is 2, so 3 into 2, sorry, at 3 the amplitude is 2, so 2 into 2 will become 4. At 4 the amplitude is 3, so 3 into 2 will become 6. At 5 the amplitude is 4, so 4 into 2 will become 8. So you will be having your signal like this. So if I take 6, definitely the 6 amplitude will be of 10. Okay. So it will be going on like that. So this is nothing but 2 into R of n minus 1. Okay. So now we have 2 into R of n minus 1 signal also, R of n also. So you can use these two signal, you can subtract both the things, you can find out x of n. Okay. So how to find out your x of n? We know what is R of n as well as 2 into R of n minus 1. Okay. So using this we can find out what is x of n. What are all the values of n? It is 0, 1, 2, 3, 4. We can take up to 5 also if you want, or you can leave. Okay. So up to your plus infinity we can take. What is R of n value? At 0 the value is 1, at 1 the value is 1, at 0 the value is 0, at 1 the value is 1, at 2 the value is 2, at 3 the value is 3, at 4 the value is 4. Okay. So 0, 1, 2, 3, 4, it will be going on up to your infinity. When I take 2 into r of n minus 1, what are all the values? At 0, the amplitude is 0. At 1, again the amplitude is 0. At 2, here it is 1 which is multiplied by 2. So, here we have 2. At 3, the amplitude is 4. At 4, the amplitude is 6. Okay, so if you want, you can take 5 also. You can find out your value. Suppose if you find out 5, here it will be 5. Here what is the value? 8. Okay, so what is x of n? R of n minus 2 r of n minus 1. So 0 minus 0 will be 0. 1 minus 0 will be 1, 2 minus 2 will be 0, 3 minus 4 will be minus 1, and then 4 minus 6 will be minus 2, 5 minus 8 will be minus 3, like that it will be going on. Okay. So now how to draw your x of n? So we have 0, 1, 2, 3, 4, 5, 6 up to your infinity. Okay. So what are all the amplitudes we have? 1, minus 1, minus 2, minus 3 and so on. Okay. At 0, the amplitude is 0 only. At 1, what about here 1? 1, the value is 1. Okay. So your signal will be like this. At 1, the value is 1. Okay. At 0, the value is 0. At 2, again the amplitude is 0. At 3, the amplitude is minus 1. So you have to draw like this. At 4, the amplitude is minus 2. At 5, the amplitude is minus 3. Okay. So you will be getting your value like this. Okay. So this is your x of n. Are you getting? So just find out your r of n, find out your 2 into r of n minus 1 and also find your x of n. So how can I draw your x of n? X of n, the amplitude is 0 at 0, right? And then what is the amplitude? 1 at 1, and then 2 is also again 0, 3 is minus 1, 4 is minus 2, 5 is minus 3. Okay. So this value is minus 1, this value is minus 2, this amplitude is minus 3, and it will not end, it will be going up to your infinity. Okay. This amplitude is 1. Okay. So this is 0 value, this is 1, this is 2, this is 3, this is 4, this is 5, and it will be going on. So this is nothing but your x of n. Are you getting? Thank you, students.